All right, guys, so this is the second lesson in Chapter 5. It's over something called ANOVA, and ANOVA is just an acronym for Analysis of Variance. So what is an ANOVA? This basically is the same thing as a t-test, but we can only t-test between two groups. So ANOVA allows us to test if there's 3 or more groups. Like in t-test, we had male and female, or juniors and seniors. An ANOVA can be 3 or more groups. So maybe instead of just comparing juniors and seniors, I want to compare like all 4 grade levels to each other. So maybe freshmen, sophomore, juniors, and seniors. We're going to look at all 4 of them. Well, we couldn't run one t-test to do 4 groups, but we can run a single ANOVA. So the key here, 3 or more groups. Okay, so assumptions. I think technically UT might say more than 2 groups, but ANOVA, just know it's 3 or more is the general rule of thumb. Assumptions. Most of these should look familiar. So the samples need to be random. You can't just ask your best friends and call it a statistic study. The observations must be independent. They should have no known relationship between each member of the study. The population of all groups has to be normally distributed, or n must be at least 30. So if we're comparing 4 groups of people, all 4 need to be normal, or the sample size of all 4 needs to be 30. Okay? The population variances of all groups are equal. This is the new one. We haven't seen this before. Variance, if you remember all the way back from Unit 1, which I know you don't, but variance is standard deviation squared. So essentially it's saying that all the groups and the means should have similar spread. You don't have one data that's basically the same number over and over, and then one data that's completely all over the place, because you can't compare good data and bad data to each other and just make for a bad study. Okay, so just like always, we've got our null and our alternate. The null is always equality. I've been stressing that for a couple months. It's not going to change. Hopefully that's ingrained in our brain by now. But the null hypothesis is equal. If we have 3 groups, then it's the mean of 1 equals the mean of 2 equals the mean of 3. If there's 100 groups, we would write that 100 times. But the null is that all groups, the means are equal. The alternate is the one that's a little weird. It's at least 1 is different. Not that they're all 3 different. So it's not mean 1 not equal mean 2 not equal mean 3. It's not that all of them are different from each other. It's that at least 1 is different from the others. Okay? Okay, now it's going to get weird. Okay? Usually you would do this by hand or in R. They're going to set it all up in this nice little chart. Okay? Which is nice. It's going to be kind of confusing because we're not going to do it the long way, the correct way. That may help you build understanding, but this way is going to make your life a lot easier, which I'm sure you're not, going to be too upset about. But there's 2 types of degrees of freedom, and then there's how you solve for the test statistic. It's been the Z score or the T statistic. Now it is the F statistic. Just why is it not the A statistic for ANOVA? No idea, but it's just called the F statistic. So the degrees of freedom between, sometimes you'll see DFB, is K minus 1, where K is the number of groups. All this is on our formula sheet too, so write this in your notes, but know that you don't have to memorize this. Degrees of freedom within is N minus K, where N is the sample size of everyone, not each group. If we have 3 groups, each group has 10 people, then there's 30 total people because 10, 10, 10. Right, so N is the overall sample size and K is the number of groups. That's how you find the 2 degrees of freedom. The test statistic F is MS between divided by MS within. Pause it if you need to write that down. I'm about to go to the chart. Here's the formula for everything. Okay, here's the chart. I've got 2 examples. But basically, they're going to give us a random assortment of these numbers, and we're going to have to fill in the blanks in the chart. Okay. SS stands for sum of squares, like SUM, not SOME, SUM. Sum of squares, again, we're not going to solve for this stuff by hand, but we do need to know how the chart works. So the sum of squares between and the sum of squares within added together give you the sum of squares total. So this SSB plus SSW is SST. So you add these two together and get SST. Same thing for degrees of freedom. Degrees of freedom between plus degrees of freedom within equals degrees of freedom total. So this is basic math, right? The total is the addition of what's above it. Mean of squares between and mean of squares within, there's no total here. But define mean of squares between, MS stands for mean of squares. Mean of squares between is sum of squares between divided by degrees of freedom between. So it's between divided by between gives you MS between. Mean of squares within is sum of squares within divided by degrees of freedom within. So within divided by within equals within. Okay. So you divide the two things to the left to get mean of squares. And finally, the F statistic is the mean of squares between divided by the mean of squares within. So you can kind of read the chart like left to right. The things on the left side of the chart work to help you find the things on the right side of the chart. We need this in our notes, so make sure this is written down. If you need to pause the video, pause the video. But make sure this is copied down exactly. Don't paraphrase, don't skip something. Write down exactly what you see on the screen. Okay, how do we know if we reject or fail to reject the null hypothesis? It is the exact same thing we've always done. Okay, the good thing is we're not going to have the table. They're always going to provide F critical for you. But if F statistic is greater than F critical, then it would be in the critical region. Therefore, we reject the null hypothesis. If the F statistic is less than the F critical, then you would not be in the critical region. Therefore, we would fail to reject the null hypothesis. Okay. This is by far the weirdest part of ANOVA testing, and then after this, I believe, is my two examples. Post hoc testing. So, definitely a typo. It's not the overall area of the study. This isn't, third grade. It's the overall error. And we only have to do post hoc testing if we reject the null. For the lesson check and stuff, if you fail to reject, this is irrelevant, okay? We only do this if you are rejecting the null hypothesis. And it's just these calculations. You really don't even have to understand what it means. In this basic stats class, we are just zipping over ANOVA because it does exist. And then if you take future stats after this, you'll go deeper into ANOVA because it's pretty helpful. But for now, we just need to know what the different calculations are and be able to solve for them when asked for them. So remember that K is number of groups. So it's number of groups times number of groups minus 1 divided by 2. And when you do the lesson check and homework, you'll see that they just ask several times for the number of piecewise comparisons. And that's just how many t-tests we need to make. Okay? And when they ask that, do that math and get what you get. Okay? The Bonferroni correction is a different type. If they ask for this, it is 0.05 is always our alpha, unless they specifically tell you otherwise. And then the number of comparisons is what we previously found using the K minus 1 thing. So it's 0.05 divided by the number of comparisons is your Bonferroni correction. So if they specifically ask for the number of comparisons, do the formula with the purple arrow. And if they specifically ask for the Bonferroni correction, then use the blue and red arrow pointing equation. Okay, I'll try not to make this video an hour, but I don't want to go too fast for those that are watching this. So when you're filling out this table, they're just going to give you a random assortment of numbers. They're always going to give you F critical. We're not going to go over how to find that, even though it's not that hard. But they're going to give you a random assortment, and we need to end up filling it out completely. Okay? So the first one's pretty easy. That's not what I thought was going to pop up first, if I'm being honest. Hold on. The first one here that I'll say, and I don't know when it's going to pop up, but 1,000 plus 400 is 1,400. So I know that this SS total is 1,400. Apparently this blank is going to pop up first, and the degrees of freedom between. So hopefully you copy down the chart, okay? So hopefully you copy down the chart from a couple slides ago, and you see that, hold on. You see that mean of squares. I thought there was a laser pointer here somewhere. So degrees of freedom between, and if you look, the mean of squares between, or the MSB, is SSB divided by DFB. Okay, so MSB is SSB divided by DFB. So if 1,000 divided by this is 125, then we know this needs to be 8. And again, geez, this is just full of typos, isn't it? So this is actually 125. That's a 1. So we know that SSB divided by DFB is going to give me MSB. So 1,000 divided by something gives me 125. That something is 8. Okay, so DFB is 8. And when I click away, it's going to lose that 1. But again, remember that that's actually 125, not 25. I need to fix that. Okay, so the next thing that pops up is this, mean of squares within. So if you look back to the chart, mean of squares within is SS within divided by DF within. Well, I have the 400, I have 38, so I just divide the two and I get MS within. Okay? So just know that the first two columns of math, I guess the second and third column, divided together give you the fourth column. Oops. So now it's what we talked about first. For the totals, you just add up the two above it. So the total sum of squares is 1,400 because you add them together. The total degrees of freedom is 46 because you add them together. The F statistic is the only blank that's left if you look at the chart that you hopefully copied a couple slides ago. The F statistic is the only thing left, and the F statistic you divide MSB divided by MSW. And so in this case, it's 125 divided by 10.5-ish, and we get about 11.8. Okay? Give or take. So here's the chart. Hopefully you wrote down the math of the chart on the previous slide. And you can think of these like little puzzles if you want, if you're into that kind of stuff. But we just need to fill in the blank using our reasoning processes of what we already know that can help us fill in what we don't know. And then our actual conclusion is, since the F statistic is larger than F critical, we reject the null hypothesis. I gave you no context here, so you don't know what the null hypothesis is, but whatever it is, we reject it because 11.875 is, in fact, greater than 3.99. We're not going to do the math because I don't want this video to be 2 hours, but since we reject the null hypothesis, we would technically need to run the post hoc analysis with the Bonferroni correction and the number of piecewise comparisons. Alrighty, so again, we have to use what we already have to fill in what we don't know. And again, it will always give you F critical, and then the other stuff is just going to be random. Okay? I mean, UT put the numbers over there for a reason, but it's seemingly random. So, one of the first things I know, and there's no correct order to this, but I do know that sum of squares total is the addition of the two rows above it. So if the total is 50 and within is 50, then I know the top number needs to be 150, because 150 plus 50 will give me my desired 200. The next one's also pretty easy, because I know the total degrees of freedom is 51. I know that the degrees of freedom between is 4. So I know the total degrees of freedom has to be 47, because 4 plus 47 will give me the 51 that I want. So now we'll move on to MSB and MSW. And we know that the mean of squares is the sum of squares divided by the degrees of freedom. So the mean of squares between is going to be the 150 divided by 4, which is 37.5. The MS within, or mean of squares within, is going to be, again, the 2 that we already have. So it's going to be 50 divided by 47, which is about 1. And then the F statistic is the mean of squares between divided by the mean of squares within. So we divide those numbers and we get 35, which is a ginormous number. And then again, for the conclusion, we've got to figure out, do I reject or fail to reject? So since the F statistic is 35, the F critical is 2.97. We know that we will reject the null hypothesis because the F statistic is greater than F critical. And again, just like the last one, we would technically need to run the post hoc analysis with the number of piecewise comparison and Bonferroni correction. But that math's not too hard, so y'all can handle that. All right, so that's the end of the video. This is just to supplement the lesson we did in class. But if you were absent or studying again, I hope this helps. If you're still completely lost and have no idea what I'm talking about, remember that UT also has videos posted. If you go to the Unit 5 folder, or the Chapter 5 folder, and go to Lesson 5.2, you can see the college professor's videos. They're pretty similar, but she's got a cool green screen behind her, so maybe they're more exciting.